In this presentation, I will do a focus on the technical system of the HAR toolkit. In particular, I will speak about the cloud platform, the DC smart fan coils, the thermal storage, the battery pack, the DC heat pump, and multi-input, multi-output converter. Starting from the hydronic part, in this scheme we can see the two water loops. A first loop between the heat pump and the storage tank, or the smart fan coils, and a second loop between the storage tank and the smart fan coils. More in detail, the heat pump can charge the thermal storage through an heat exchanger, or directly provide heated or chilled water to the smart fan coils. In alternative, the storage can be the thermal source for the smart fan coil loop. As you can see, supply water temperature in the fan coil loop is between 20 and 25 degrees Celsius, thus minimizing the distribution heat losses. Different valves and circulation pumps allow the proper management of the thermal fluxes. In this scheme, you can see instead electric interactions. The key element of the electric system is the MIMO converter, which manages the interaction among the grid, the photovoltaic system, the batteries, and the DC appliances. Batteries are not a product of the research, and any market component can be adopted and connected to the converter. More in detail, the MIMO converter can power DC appliances at 48 volts in the case of smart fan coils, or at 550 volt in the case of the heat pump, using three different sources that are the photovoltaic system, the battery, or the grid. In case of surplus of photovoltaic electricity, the converter can work as a battery charger and store the energy, or act as a DC-AC inverter to inject electricity into the grid. This configuration doesn't interact with the domestic electric systems, which remain autonomous with the traditional AC power. Here you can see a more detailed scheme of the MIMO converter. It is equipped with 4 DC ports working at different voltages and an AC port operating at 400 volt to be used for the grid connection. The converter is conceived as an all-in-one component to simplify and speed up its installation. The DC heat pump has instead a separated internal and external unit with a nominal thermal power of 20 kW. The outdoor unit has a modulating fans and an optimizer design to ensure a low sound emission. The heat pump ensures high efficiencies also at low air temperatures. As mentioned before, the power voltage is 550 volt. The other DC component of the toolkit is the smart fan coil. It is conceived to be installed in place of existing radiators and is able to provide heating and cooling, working as a water-to-air heat pump. The condensation water produced in the cooling season is pumped directly in the main hydronic loop, avoiding the need of a drain. On the right side, you can also see the sides of the fan coil, which is a compact element and can be easily installed in existing dwellings. Here you can see some pictures of the component during the tensing phase. The last picture on the right shows the version to produce domestic hot water with an integrated water tank. This is instead the thermal energy storage with phase change materials. The component is able to store both sensible and latent heat, increasing the storage density compared to a traditional water tank. The total capacity of each tank is 1000 liters, equivalent to around 40 kWh of thermal energy. PCM are in form of plastic balls that can be easily transported and inserted in the tank just when it is installed. Finally, this scheme shows the fluxes of data. In this case, the key element is the building gateway, which collects information coming from all devices and manages the interaction with external services, such as the weather forecast service. Within the building, all data are transferred using wireless protocols to avoid the installation of additional communication cables. More in detail, both Wi-Fi and narrowband IoT standards are adopted to allow the communication among fan coils, the MIMO, the heat pumps, and the building gateway. Such a gateway also integrates a 4G modem to exchange data with the Earth Cloud platform, which acts as an energy management system.